Hello and welcome to our Design 2 project, brought to you by Zishuo, Dong, and Mustafa. The purpose of our project is to learn and apply the basic concepts of Lean and Six Sigma. We want to apply those concepts onto a real-life problem in order to produce an assembly line that is optimized to the best of our abilities.
In this presentation, we will follow this outline to recap the previous design and improve it by using 6S techniques. The product in question is a certified brand massage machine. For the purpose of this lab, the product has been disassembled into 8 components. Specific components to the massage machine will be referred to as follows. In our assembly line process, there are 10 different taxes to assemble.
Our initial line from Project 1 consisted of 5 different stations. It had a cycle time of 1.1 minute per unit and was only able to produce 2,166 units in a week. While we did achieve an efficiency of 92.7%, we had to do that by exceeding our 8-worker limit and appoint 9 workers.
We will focus more in depth on 3 of 4 required improvements listed here. The first issue with the assembly line is the assembly process has too many different types of screws, which are hard to identify. The second issue was a strain on the worker of using a manual screwdriver to continuously complete the repetitive motion. The third issue we found was with unskilled and trained workers. The fourth issue that was inconsistent product quality. The issue will not be addressed further in this lab, but it should be brought up to the manufacturers of the component.
Our metrics to measure the success of our improvement are the reduction of cycle time, the reduction in station time variability, reducing the cost of labor to produce one item, and maintaining a high efficiency while increasing our total output.
The concept of success. We decided to choose the 6S concept to improve our assembly line. 6S is a common technique to improve the manufacturing process. The process of success developed in Japan and can be roughly divided into 6 steps. First, the sort means we need to inspect the work area and keep only the necessary tools and materials for efficient working. Our problem is the working environment is messy, and our solution is remove the item and the material not needed for the work and put the tools you need nearby. Second is set in order. This step deals with organizing tools, equipment, and other items by grouping them based on their function, putting labels, and place them in specific areas so that workers can easily reach them when they need it. Hard to find the part. The solution is place the necessary item left in according with the prescribed position, and place them nearly and mark them. We also can different kind of tools placed at different fixed places. Storage of material. The above diagram is our 4 workstations. We have placed 3 boxes for each workstation to store different types of screws. Also, we have placed screwdrivers on the left, and we place different assembly parts on each workstation. This is based on the previous 2S, which can improve our assembly line efficiency. The third part is shine. Clean the part tools and the work area on our workstation to ensure that workstation is available to work. Our problem is unnecessary dust on the workstation. Some parts appear on the workstation in a mess. The solution is use the tools and keep the workstation environment tidy and put different parts back to where they were before. The fourth step is avoid people partially or fully forgotten to do the earlier step and engaging in old habit of inefficient working. Our problem is the assembly process have too many screws, different types of screws, hard to identify. Solution is we explain 6S to employees and break down their main responsibility, and check the cleanliness and formulate a detailed checklist. Also, we posted the name of the person in charge in the area he responsible for. We create a table of shine, sweep, and scrub form. This can ensure that we can clean every small step. We confirm the requirement on the form after completing and cleaning each item. This will further ensure the safety of the working environment. We also arrange a quality inspector in each workstation to ensure the conformity of our products. In this way, when an error occurs, it can be corrected in time. The fifth step is to sustain. This step is about continuously doing good things and letting the routines become mature and ingrained in day-to-day project work. Our problem is workers have no experience, and the solution is we can establish rules and regulations, and we can visualize the rules and regulations plus operating procedures. Also, we need to always monitor and correct the errors as soon as possible. We can make improvements and to do better. In recent times, safety has been added in 6S model. This step involves ensure that the operationalization of work and the work environment meet required safety standards. Our problem is workers will be injured due to the improper use of a tool. Our solution does occupational health and safety training for employees and post a warning sign of occupational hazard, for example, wearing the safety glasses.
Since our assembly process had a total of 26 screws in 3 different sizes, it was evident that something needed to be done to improve the tedious process of tightening a screw manually. Therefore, a simple solution was to implement a lightweight and ergonomic electric screwdriver designed for heavy production applications. The solution to our second problem of the connection between the circuit board and power cable being fragile was to include a buffer between the stations. In the case of the wire breaking, the station can quickly restart work as the part will be rendered obsolete and the joint has to be resoldered again. Another solution was to wrap each connection with 20 centimeters of electric tape. This solution is easy and simple to implement since it only adds 10 seconds to the total production time of each item, and it has a very low cost as will be discussed later in the presentation. If we compare our cycle time before and after implementing solutions, we see that 7 of our 10 tasks had a reduction in their time. Also, all station cycle times improved as well. Total cycle time went from 556 seconds to 434 seconds. The corrections was the same as the mean after the improvements. We tested this hypothesis at a significance level of 5%, and we found that the probability of T being greater than 4.7 is 0.2%, which is significantly smaller than alpha. Therefore, we reject the null hypothesis and accept that the means are in fact different. We also see that we have significantly reduced station time variability from 9 seconds to 6 seconds.
Our new balance line after improvement by 6S techniques and the electric driver for workstations, and we set a buffer between every stations.
Comparing our new balance line and initial line, we were able to reduce the number of stations from 5 stations to 4. Also, cycle time was reduced from 1.1 minute per unit to 0.97 minutes per unit. So the new line was able to achieve 294 more units per week at a 90% efficiency. Labor cost per unit produced is also decreased by 40 cents per item. We wanted to see if the cost of our improvements is justified. For the electric screwdriver, it would cost $200 to implement and would offer savings of about 40 cents per item. In the long run, this means a total of $985 per week will be saved. For the addition of 20 centimeters of tape per item, it would cost about 3 cents per item to implement. This translates to about $74 a week in extra expenses, but it will drastically reduce the chances of a broken connection.
As earlier, we stated the metric of improvement. We improved those requirements one by one. After applying the 6 techniques and add some tools to the workstation, like the electrical screwdriver, the assembly line generally increased 12% in cycle time, decreased 21% in labor cost per product, and 33% less station time variability. To sum up, we were able to analyze the following problems: reducing the cycle time in assembly line, reducing cost, and then we use lean engineering techniques, 6S techniques, to implement solutions that were more sustainable design for the assembly line. Thank you. This is our presentation.